Okay, hello, welcome to my channel. My name is Solo Ange, and in this video, I want to evaluate this limit without using the L'Hopital's rule. Okay, so I saw this question right here on Reddit. I asked, how can we do this right here without L'Hopital's rule? So right here is the solution to that. So you notice that, well, do we really need the L'Hopital's rule? So let's look at this. As x approaches pi, all right, either from the right or from the left, this cosine here is a continuous function all through. So yeah, it works. So look at this. As we approach as we approach pi, cosine of pi is -1. It's approaching -1. By substitution, this should be square root of 4, which is 2 minus 2, that is 0, divided by pi minus pi. Okay, by substitution, that will be 0 over 0 situation, which we will probably use L'Hopital's rule, but we are not allowed to use the L'Hopital's rule. So yeah, our solution will be without the L'Hopital's rule. Okay, so maybe let's just do this right here. So let me start off with the solution. Great. Okay, so let's see what we have. Well, I'm going to start off with the function without the limit. So let me write the function. So we have the square root of, okay, let me put it out here, the square root of 5 plus the cosine of x. Okay, and then we subtract 2 from that. We divide this result by pi minus x. Good. Okay, so what can we do here? Well, since I have a square root, I don't like to have the square root like that. So what I would do is to multiply the numerator and the denominator by the by something. So let me show you what that would be. That is going to be multiply the numerator by the square root of 5 plus the cosine of x. But here I'm going to change this sign to +2, all right? And then we have this as the square root of 5 plus the cosine of x, and then +2. So right here, I don't want to. It's not going to be a conjugate, because in that case, we may assume complex conjugate. But just a trick. Just change the sign here, all right? Okay, so let's see what this will give us. We're using the fact that when we factorize difference of two squares, we get something of this form. This should be the square of this minus the square of that. So that will be 5 plus the cosine of x, all right, minus the square of 2, which is 4. That is when we multiply the numerators. The denominator will stay the same. We are not going to expand that. So this is pi minus x times this right here. Maybe let me put the 2 in front. So that will be 2 plus the square root of 5 plus the cosine of x. Okay, that's nice. Good, but you notice that 5 minus 4 is going to be 1. So let me put this here at 1. Then 1 plus the cosine of that. All right. Okay, so I've removed the 5 minus 4, leaving us with just 1. So what I will do here as the next step is to multiply numerator and denominator by 1 plus the cosine of x. So here we just do some trick, 1 minus the cosine of x. Yeah, and that could be by multiplication and division, whatever, just to try to see where you can get. Okay, no, I tried this a few times before I could get up with the solution, and that's why I'm just doing it straightforward without having to beat around. Good. Okay, so let's notice what we have. So I've multiplied numerator and denominator by 1 minus cosine of x. This is 1 plus cosine of x times 1 minus the cosine of x. So multiplying this and that together, notice we're going to have 1 minus cosine squared of x. And by trigonometric identity, that is just equal to the sine squared of x. Okay, sine squared of x. Then the denominator is pi minus x. So we have here to be 2 plus, I'm going to write everything again. Okay, that's very nice. So maybe let's move up. So let's see what we have. Well, this is equal to, I'm going to split this sign to sine times sine. All right. In fact, I'm going to split the fraction into two fractions multiplied together, and that will be by taking this sign, one of the signs here, by and pi of minus x in the denominator. So this is going to be sine of x, okay, divided by pi minus x. Good. We multiply that fraction by, well, this other sign divided by the remaining part of the denominator. So that will be sine of x divided by this right here. Okay, so that's it. So we started with the function which we want to evaluate the limit as x approaches pi, and then we've entered with this. So I'm going to say that the limit, okay, the limit as x approaches pi, excuse me. Okay, sorry about that, my light was down. Good. Okay, so let's see what we have. So we start off with the limit. Okay, so the limit of this function, but we've rewritten this function as that. Okay, so I'm going to write the limit of, instead of this, I'm going to put this down. And in fact, I'm going to use the fact that the limit of the product is the product of the limit as well. So that will be the limit of this part times the limit of this part. So let's just put down the functions. So that will be sine of x. Okay, sorry, that is sine, not 6. Sine of x divided by pi minus x. That is the first part of the limit. Then we multiply it by, so let me put it out here. Good. So times the limit of this other one, that will be times the limit as x tends to pi of this right here, which is sine of x. What is wrong with 6? Divided by this denominator. Okay, that's nice. But there is this wonderful property that, that when we have sine of, let's say, pi minus some angle, the result is the same thing as sine of that angle that we subtracted from pi. And you can think about this using the sine of sum or difference of two angles, that sine of pi minus x after the expansion, you know, sine of, and let's say a plus b, or a minus b will be sine a cosine b minus cos a sine b. Good. So in this case, it's going to be sine pi cosine x, but sine pi is 0, so that first term will be 0. Then we have minus cosine pi sine x. So given that cosine of pi is -1, then the sine x will just be left. So given that this right here is true, since sine pi minus x is the same thing as sine x, in the place of sine of x, I'm going to put down sine of pi minus x. Good. So this is the limit as x approaches 0 of sine of, so in place of x, I'm going to put pi minus x. Right? Good. That is just from the trigonometric identity. So maybe let's just say this right here comes down. Okay, I'm not going to do anything with it for now. Good. So this is going to be, well, notice something. Sorry, this is not x approaching 0. This is x approaching pi. Okay, that's what we have over here. So notice something, as x approaches pi, that is, as x gets closer and closer to pi, okay, this angle is approaching 0. That is, their difference gets closer to 0. Their difference approaches 0 as well. So that is, we are having sine of an angle which approaches 0 divided by the angle itself, which is approaching 0. So it is a well-known limit that when we have the limit, okay, let's say as an angle theta approaches 0 of sine of the angle divided by the angle, that the result is just going to be 1. And we can prove this using the unit circle, okay, not using L'Hopital's rule, but using a limit circle, the unit circle. And that's not because we are not allowed to use L'Hopital's rule, no, but because it will be a circular reasoning to use L'Hopital's rule to evaluate this limit. Okay, so using the fact that the angle is approaching 0, so since pi minus x is approaching 0 and this right here is approaching 0, it means that that limit will be sine of this over that, which is just going to be 1, using this result right here. Good. So maybe let's draw this right here. So this comes down to that. So that means altogether what we have is that the limit of this function is equal to 1 times this part, which will just be this part, all right? But notice that as x approaches 0, as x approaches pi, substitute pi for x here. Sine of pi is just 0. So this is 1 times sine of pi is just 0 divided by, let's investigate the denominator. Cosine of pi is -1. 5 minus 1 is 4. Square root of 4 is 2. 2 plus 2 is 4. So we have 4 right there. Times, well, 1 minus cosine of pi is -1. That will be 1 minus -1, which is just 2. So the denominator is non-zero. Meanwhile, the numerator is 0, which gives us 0 as a result. So in fact, this limit right here is equal to 0. You know, one thing about 0 is like nothing. It's like you did all the work and got nothing. Anyway, I hope you like the video. Please share this video with your friends. Please subscribe to my channel. I will see, I will continue, or maybe in fact, let me say, calm down. And whatever you see is good, please do for me. Thank you.